Hey everyone, let us start with question number 19 of ISI MSQMS 2023 question paper. So in this question you can see that it is given the area bounded by y is equals to kx square and x is equals to ky square for k greater than 0 is 1. So then the value of k is, okay. So first of all let us try to draw the graph here, that is, say this is, so the upper curve looks like this, that is y is equals to kx square, that is like this, and the lower curve is here like this. So as you can see that there is a point of intersection where these two will be equal. So now our first work, okay, the other thing according to this question is the area bounded by these two curves, that is this part, that is given as 1. So first I have to find out this value, right? What is the value here where these two are equal? So for that, first let us take this, that is y is equals to k x square, y square is equals to k square x to the power 4. Now from here we already have y square is equals to x by k, right? So I can substitute it here, that is these two are equal means x by k is equals to k square x to the power 4, or 1 by k cube is equals to 1 by x cube, that is x is equals to x cube, this should be x cube, right? Yes, so that is x cube is equals to, because we have taken x here, so x4 by x is x cube, and this is 1 by k cubes, that is value of x is equals to 1 by k at the point where these two curves are equal. So I can say that here the value of x at which these two curves are equal is 1 by k. So 0 to 1 by k. So this is the area that is bounded, right? So I have to integrate in order to find out the area between these two curves, between 0 and 1 by k. So now, so the area here will be a is equals to, so we will integrate within this range, that is 0 to 1 by k. Now we are going to take the area of the upper curve, right? That is for this one, y of upper curve. That is y is equals to root x by root k. That is root x by root k minus y upon the lower curve, which is here kx square. So minus kx square dx. Now this area according to the question is equals to 1, or now let us solve this. So let us take 1 by root k here, that is constant, integration 0 to 1 by k root x dx minus k integration 0 to 1 by k x square dx. This is equals to 1, or 1 by root of k, this is x to the power 3 by 2 by 3 by 2 interval 0 of to 1 by k minus k of x cube by 3 from 0 to 1 by k is equals to 1. So let us put the values here. So if we substitute the values, we will get 2 by 3 root k into, this becomes 1 by k whole to the power 3 by 2 minus k, again here this is k by 3 and this is 1 by k to the power whole cube, and this is equals to 1 again, or let's simplify this. So this is 2 by 3, correct, k to the power half, and this part is basically into k to the power 3 by 2 minus k by 3 k cube. This is equals to 1 again, So this k and this k cube gets 3k square here, and here we have 2 by 3 k 1 by 2 plus 3 by 2. Now 1 by 2 plus 3 by 2 is 4 by 2. So that is or 2 by 3 k, that is 4 by 2. So this is k square again minus 1 by 3 k square is equals to 1. Or so this is 2 by 3 k square minus 1 by 3 k square, which is equals to 1. So 2 minus 1 is 1. So 1 by 3 k square is equals to 1. So or k square is equals to 1 by 3. Therefore, the value of k is 1 by root 3. And this is the answer. Let us have a look at the options. Let's go up, up, up to the question. And we have our answer, that is option B is the correct answer. Let's look at the next question. The question in front of you says that consider the equation minus x squared plus alpha x minus beta is equals to 0. So you have to say for what value of alpha and beta, basically the value of x, that is the root of x, will be distinct roots. So this is the very easy question, because in these type of questions you can make use of the options to find out the answer without going into details. So how can you do it in very quickly is, first write down this equation, that is minus x square plus alpha x minus beta is equals to 0. So this can be written as x square minus alpha x plus beta is equals to 0. Now use the options, put the values and find out the roots. So if you get the distinct roots for the following options, so whichever option is correct, you can mark it. So let's start with the first option, that is 5 and 4. So if I put alpha is equals to 5 and beta is equals to 4, then I get if the equation is x square minus 5x plus 4 is equals to 0. So let us take the help of middle term factorization, right? So here x square. So this is 5x. So so basically here we can use minus of 4 is right. So the middle term factorization of 4 will be, so 2 to the 4, so 2 to 4 is not right. So basically 4 and 1 we can use, right? So x square minus 4x, or let's say, sorry, x square minus x square minus x minus 4x. So this becomes minus 5x, and 4 ones are 4, so this is correct, is equals plus 4 is equals to 0. So if we take x is common, we have x minus 1, and minus 4 is common, again I have x minus 1 is equals to 0. So x minus 4 and x minus 1 is equals to 0. Therefore the roots are x1 is equals to 4 and x2, let's say, again root, that is 1. So real and distinct. So we have got our answer, that is alpha is 5 and 4. So the answer is A. The next question here is given 7 to the power 300, and you have to find the last digit. Okay, so first let us try to understand. Say if we take 7 to the power 1, the last digit will be 7. For 7 square, the last digit will be 7 square is 49, that is 9. 7 cube, then the last digit will be 3. 7 to the power 4, the last digit will be 1. And again, when we repeat, like with this, if I go for 7 to the power 5, then again the last digit will be 7. That means after every fourth power, we will repeat this pattern of 7, 9, 3, 1, right? So what I'm going to do is, let us first write down this, that is, we have 7 to the power 300. Let's break the power, that is, let me write down it as 7 to the power 4 whole to the power 75, right? Now I know 7 to the power 4, the last digit will be 1, so the last digit here is going to be 1 to the power 75, which will always result in 1. So this is the answer. That means option A is the correct answer. The next question here is, you are given an expansion that is 2 by 3 factorial plus 4 by 5 factorial plus 6 by 7 factorial, and we have to find out the value of this expansion. So first let us write down the general way of this expansion. As you can see, it is basically 2, and this is 2 into 2 plus 1. Again 2 into 2, so 4. So again this is 2 into 2 plus 1. So this is, there is a sequence. Okay, so we can write it down as, say, summation 2 by 2r by 2r plus 1 factorial, r is equals to 1 to infinity. So means, see, if you put the value of r is equals to 1, then you get 2 into 1 by 2 into 1 plus 1, that is basically 2 by 3 factorial, the first term. R is equals to 2 means 4 by 5 factorial. R is equals to 3 means 6 by 7 factorial, and so on to infinity. So that is why we have written a general structure for this expansion. Now let us add and subtract plus 1 minus 1. Okay. So now this can be written as summation r is equals to 1 to infinity 1 by 2r factorial plus 1 by 2r plus 1 factorial. So if you look at it carefully, then if you take the LCM of this and solve, then you will get this result, right? So because see, LCM of this will be 2r plus 1 factorial, so like by taking the common factor you will get 2r here, and so hence you will get 2r by 2r plus 1 factorial if you take the LCM. So we have written it in this form. Now, so the series will become like this. Let us put the values of r here. So what do we get? When r is equals to 1, this is 1 by 2 factorial. Okay, this should be minus. I'm sorry. There's a mistake here. Yes, this is minus. Then we will get this. Okay, so 1 by 2 factorial minus 1 by 3 factorial. When r is equals to 2, we have plus 1 by 4 factorial minus 1 by 5 factorial. Again, plus 1 by 6 factorial minus 1 by 7 factorial, and so on, right? Now suppose with this expansion, I am going to add and subtract 1. Then this expansion is basically the expansion of e to the power minus 1, and which is the answer. So that is option A.